So the next thing that we're going to learn how to do in SMAK is processing multiple energy maps.
The objective of multiple energy mapping is to produce maps of the different phases of your element of interest. We accomplish this by mapping at several different energies across the absorption edge of the element of interest, indicated in the figure by the vertical lines. In this example, you can see that there are unique features in the absorption edge that are captured by mapping at these discrete energies. It is important to consider which energies you will be mapping at. You select energies based on what you already know about or expect to find in your sample. It's important to choose energies where you find the maximum difference in the absorption coefficient between the different phases. What you see here are 5 different iron maps collected at 5 different discrete energies within the iron absorption edge, based on what we already know about the sample. The end goal is to produce maps of the different phases that are present within your sample. Shown here is an example that illustrates the difference in the distribution of iron 2 and iron 3 within our sample.
So let's get started. Processing multiple energy maps involves several steps, several of which you will already be familiar with. To start, you'll need to apply the dead time correction to each element of interest at every energy. So if you're looking at iron, you'll want to dead time correct each iron map at each energy. For help doing this, please see SMAK Tutorial 3, Data Processing. The next step is to pull all of your iron maps into a single file. For this, it's usually best to start in your highest or lowest energy file. Click on Import Data From in the main GUI. Then select the file where you saved each dead time corrected map for each iron energy. You will then be prompted to select which channel to import. Select your iron channel and click the OK button. You will then be asked to rename the channel. I find it's easiest to have the element abbreviation followed by the energy that the map was collected at. The new channel will then be added to the end of the list of channels. The next step is to perform principal component analysis on all of the channels of your element of interest. PCA analysis is also covered in the SMAK tutorial for PCA analysis, but I'll go over it here briefly. Select Analyze in the main window, then select PCA on Channels. Scroll down and find your first energy map. Select it, and then hold down Shift and select the other end of the energy spectrum. Then click the PCA button. The PCA analysis can take some time, particularly if your map is large. Be patient. If you want to know if it's working, you can see the Working on PCA will appear in the bottom left-hand corner of the main window. When it's finished, the components will appear at the bottom of the list of channels. It's important to remember that the number of components that are generated by the map will be the same as the number of channels that you did PCA on, or those components may not be real. During PCA analysis, it's often useful to look at the black window that is accompanying SMAK. One way that people often use to look at the number of components that they have present in their system is by looking at the indicator function, indicated here by IND values. And the minimum of that function is often associated with the number of components that are present in the system, although this is not a fail-safe method. It is a frequently used guide. PCA maps are not positive or negative, and so it's often important to invert your data to look at both the positive and negative portions of the map. In the example that we were talking about in the beginning, there were 3 components that were identified in the map. These are shown here in addition to the locations of the XANES spectra that were collected. This is the topic of the next tutorial. Keep on trucking to learn more about how microXANES can help you interpret your multi-energy maps.